If you've been around the internet, you couldn't help but notice a contentious debate that goes on between creationists, people who believe in a literal interpretation of the first two chapters in the book of Genesis in the Bible, and evolutionists, people who believe that life on Earth resulted from random mutations followed by natural selection. Well, Bayes' theorem has a lot to say about the outcome of one of the battles in this war between evolution and creation. Now, why would I pick such a contentious issue to illustrate Bayes' theorem? Well, it's because I want to show you that Bayes' theorem is not just some mathematical curiosity. Bayes' theorem is very relevant. Now, in this battle, evolutionists have the burden of proof. After all, evolution is a scientific theory, and scientific theories need to be supported by evidence. Now, what kind of evidence would be useful here? So what you want is evidence that pulls in as much of the hypothesis as possible. You can see here that varying amounts of the hypothesis can exist inside of the red evidence bubble. Statisticians even have a name for this. The amount of possible universes where the evidence correctly hits the hypothesis compared to the amount of possible universes where the evidence is found but the hypothesis is incorrect is called the likelihood ratio. The better the correlation between the hypothesis and the evidence, the higher the likelihood ratio. If the evidence completely swallows up the hypothesis, then your hypothesis is totally falsified if the evidence turns out to be negative or wrong. One piece of evidence that does this for evolutionists is comparative anatomy, or homology as it was called by Thomas Huxley in 1863 when he first used it to argue for human evolution. The argument goes like this. If wolves, rabbits, penguins, apes, and humans all evolved from some common ancestor, then we should all share some common anatomical traits that support the activities necessary for life. So things like movement, metabolism, and reproduction should all be accomplished with similar bones, muscles, organs, and structures. Well, over the last 150 years, zoologists have done extensive comparisons of skeletons, muscles, nerves, and body organs from different animals. So much functional and structural similarity exists that we can organize every animal, living or extinct, into one huge phylogenetic tree, or tree of life as they call it. I'm sure you've seen it in your biology textbooks. And there's thousands of new species discovered every year. Now, why is this good evidence for evolution? It's because our hypothesis is deeply embedded in the evidence. It has a high likelihood ratio. The theory of evolution demands that large sets of these anatomical structures can be classified according to the similarity of selected traits in order to show this long, gradual line of progressive animal changes. Now, along with this high likelihood ratio comes a risk for evolution theory. The theory of evolution would be pretty well falsified if the evidence comes back negative. Even if a small amount of evidence doesn't fit the model, like if we find animals with radically different body designs that don't fit into the tree of life, then evolution theory is killed. Strange animals with unusual organs would need some other theory than evolution, like special creation by a designer. I don't think you'll get much disagreement from this on either side of the debate. Now, what about the size of the evidence bubble, E? Now here's the guts of the debate. If E is tight around the hypothesis bubble, then if confirming evidence comes in, after we eliminate the universes where the evidence is false, we're now left with a set of possible universes where our hypothesis, evolution theory, occupies the lion's share. Now the evidence is tight around the data when the evidence is something that's surprising to us, something that you wouldn't expect in many of the universes if our hypothesis wasn't true. Now, is the red evidence bubble tight around the hypothesis in our situation? Well, my opinion is that it's tight. And this is what the biologists are telling us also. My reasoning is this. The Lord Jehovah, the Creator from the Old Testament, could have done anything he wanted. He could have gotten creative here. There's no reason he had to make all the animals appear to fit together in the phylogenetic tree the way they do. My opinion is that making the species only seem to be ordered would have been deceptive. And we don't want to think of our God as someone who would deceive us. So there should be comparatively few universes inside our red evidence bubble where all the species are organized into one phylogenetic tree. But since the evidence has come in positive so far, evolution is confirmed to a pretty large degree. After seeing this evidence, we now know that we live in this universe. So the way it appears to me is that the relationship among the various biological species gives a huge boost to evolution theory. Now, you don't have to agree with my assessment. You might believe that God just did it this way, that he organized life into one large phylogenetic tree, that we can't really look into the mind of God and we don't know what he intended. Well, first off, I have to say this sounds phony. It seems like an adjustment we're making simply designed to protect our creation hypothesis. Well, if you do that, you can skew your results, and that's a big no-no in science. But I can't look into your mind, and I don't know whether you have a good reason or not for this. Now, if your argument is that we can't understand God, and we can't predict what he would have done when he created life, there is a way to deal with this. When you have no reason to expect the evidence to be one way or the other, then you have to use 50%. If you use anything other than 50%, you must have a reason for it. I'll show you what I mean. Here, I'm going to flip a coin, but I'm not going to tell you what it came out as. I'm going to ask you, is it heads? Well, you have no idea one way or the other. So half of your potential universes contain a reality where the coin turned up heads. And since no fact in any of your universes affects the outcome of my coin flip, you have the exact same number of possible universes where the coin might have been tails. And at this point, you don't know which of the universes on your plate is your reality. So the chances of you living in a head universe or a tails universe are 50-50. It's the same way for our red evidence bubble. If we truly have no instinct on what God might have done, then we'll have to use 50-50. This has been shown conclusively to be true by mathematicians over the centuries, and especially those who were gamblers. If you incorrectly bias your predictions, then your opponent will just take your money. What? You didn't think that the ancient people invented mathematics just because they liked numbers, did you? So if we use 50% for the probability of the evidence, then our red evidence bubble contains half of our possible universes. So now look what happens. After receiving confirming evidence, our hypothesis, evolution theory, is twice as likely as it was before. Evolution theory receives a boost, but not nearly the large boost it got when the red evidence bubble was tight around the hypothesis. If you thought evolution theory was 10% likely before this evidence came in, because it occupied 10% of our potential universes, it's now 20% likely after half of the potential universes are eliminated. Anything else is dishonest, given a 50% evidence bubble. This is the most accurate way to evaluate the evidence. It's the backbone of clear thinking. It's used in science, law, and journalism, when everything's going the way it's supposed to anyway. If a theory survives falsification, it gains territory compared to theories that don't make a claim one way or the other. A theory that has no relationship to the evidence is not made any more or less reliable when that evidence comes in, compared to theories that stick their neck out. This should be astonishing to you. This is part of the reason that science works. If you had science in high school or college, you probably learned the methods of science, but I bet nobody ever explained to you why you should trust science. The Bayesian revolution is fairly new. In the next video, I'm going to show you what happens if we try to increase the evidence bubble to a size larger than 50%. If you do this simply to try to protect your pet hypothesis, then you may actually be damaging your hypothesis. Please tune into the next couple videos. I think you're going to find this really exciting.